So now we've got the audio working in this LUFS, which is the main thing we wanted to do. Let's tidy up some of the code. Let's clean up this main view now. Making the audio calculations is really independent of the Avalonia UI. So we'll tie all the UI in and provide nice helper functions, and then we can work on the actual audio specific code in the background. As soon as we've done all this cleanup here on the left, we're going to move on to the final stage, which is this graph on the right, which will be a moving and colourful graph and quite fun to do. No idea how we're going to do it yet, but let's clean up our code and get all this UI bound before we move forward. So when you're developing and testing, like we were to find the best way to just capture audio for now, there's no point making interfaces, binding them, using MVVM. You just dump the code in like we've done until you find something that works, and now we need to go back and clean up this code. So the simplest thing is I'm just going to start from the top of the main view file, work down, and take a look at what I feel needs to be moved out to an audio capture service and clean it up into an actual interface. So we have the audio capture service here, which uses base, and so far we have a fireback when data's available and a start and stop, and that's it. We don't have any processing yet, and it's also, I don't think, not bound to our audio interface service. So the capture service and the interface service we can probably combine for the most part, I think. I don't think the app's big enough to need this to be separate, so we'll probably merge this audio interface with the actual capture service and rename this to maybe audio capture service. So let's just start with that. Rename that to capture service. We will simply cut this out. We will make this audio capture service. We'll paste this in here. We'll also rename the interface. Delete the dummy capture. So now we have the combined service with an interface ready to add extra functions to. Let's go back to, let's close everything we don't need for now. We need to fix this, which is the main view model. Now to have iAudio capture service. And then if we new it up, we don't have a dummy one for now. So we will literally use the audio capture service. So this newing up of the model is for design time only. So this is why it's injected here. Apparently we don't have a default constructor, so let's just make the default ID, I believe 0 was default, I think, but I'm just going to put 1 in for now because that's what we're using in our code. That allows the dummy creation. So the view model's clean, the capture service is clean. It's now this main view that we need to do most cleaning up on. So all we want to do is scroll through and see what isn't the main view and start cleaning it. So we have the audio capture service, and now's a good time to add the comments. The audio capture service to provide audio features to the app. The main view model of this view. And all these comments will come out if you do auto-generated documentation as well. So it's important to comment absolutely everything. Otherwise, as silly as it sounds, when you then generate your automatic API documentation, if this ever turns into APIs or just public documentation, this just saying capture device with no information whatsoever might confuse the end user. So it's always best to describe everything. The LUFS and the capture frequency I don't feel are members of the main view. Certainly not the view. They should be parts of a view model, if nothing else, or a capture service. So I'm going to move these two for now into the audio capture service. And let's start commenting these as well. The LUFS, as we saw, were, I actually don't know what they were, I can't remember. Let's have a look. So this is part of calculating or trying to calculate the LUFS over a set of samples. So really it is actually LUFS as well. Yeah, we do calculate it. So that will be the last few sets of captured audio bytes converted to LUFS. frequency to capture at. And this might seem a little bit boring, but this is an important step. Now we know that we're on the right track with what we're doing to properly clean up your code again. We don't need to output that anymore, so let's get rid of the comments. Again, another important thing, as desirable as it is to leave comments in with helper code, once you've done that, really try and just clean your code up and get rid. And you can always fall back and, do that again if you need to in the future, but try not to just leave loads of commented code. It looks messy. So calculate values. I think this whole calculate values is something that just needs to live in the audio service. So I'm just going to cut that entire thing. Minimize private members. I'd say the calculate values would probably get fired. Like this, output all devices. And see, this one is probably usable for WAV file writer. So it's not that obvious how we do this either. So I'll probably leave this comment in, just because that's something that would maybe be a little bit tricky to discover. Although, would it really? WAV file writer, new format. Yeah, I'm just going to leave that one in because I've got a feeling we will want to add this to the actual application. It's not necessarily dummy code. That's just a feature we probably want to add to the app later on. Let's leave that in. Initializes the audio capture service and starts capturing the specified device ID. Now, I don't know whether you really want to do what we're doing here, which is initialize it and start it straight away, because then this is a service that can't stop and start. So we're going to have to rejig this in a moment. So audio capture methods. This is the callback from the audio recording to process each chunk of audio data. And user, I don't even know what the user is. We'll leave that blank until we find that out. Let's now plonk in, I reckon it's capture audio methods. Calculate values, and it looks a bit messy just going back and forward for now, but that's how we refine the code. So we have start capture unloaded, which is on 1. So now we spin up this. Capture frequency is defaulted already, I think, so we'll remove the capture frequency from there. And then, yeah, we call start, but I guess, yeah, I'm just not keen on this kind of an audio capture service for a device, but I guess in one way, you can have as many capture services as you like and just specify a different ID, and it keeps it encapsulated to that device. So, to be honest, we probably will. It's just when we inject this service, where do we inject that service? So it's in here. So this is why I don't think we should do it, I think. In main view model, why do we have the capture service? So, in the main view model, we are capturing yeah, that's a point actually. In this main view, we probably want to remove almost everything from this. So I don't think we even want this capture service in the main view, because the audio capture service isn't a view model. Yeah, that's a point. This is a service, not a model, and the view shouldn't be in any way responsible for the services, I don't feel. This should be a view model specific thing. So we actually want to cut that out completely from the view, and the view model should take over that. And you can see it's already started to do that here. So this is the audio capture service. And there should be absolutely no binding to the service whatsoever in the view. We need to step it right the way up through the view model and bind it back down. So let's just carry on chunking through this and moving things around. Container size is fine. Unloaded start capture. Now again, we have load settings command. So we probably want to move the start capture into a load settings or a load in general. So I think we should also rename that to just load command, so that the view model has a generic load command to do something with. and it hasn't renamed that, so let's just rename it ourselves. Load async, and this is do initial load of data and setting up services. So in the view model now, when it loads, we get the channel configuration, we bind it to the view model property, and now we also want to start capturing. So if we go back to here, this view has no other intention other than to tell the view model to load, which is now correct. Run on load initialization code. This function updates the application window control sizes dynamically. Now the start capture needs to move out completely. We'll put that into the main view model, and that can be, it's not a command, so let's move that out to constructors done, second constructors done, initialize. So we need to clean up initialize, so we'll come back to that in a moment. And that shouldn't be in constructor, to be honest, because constructor is constructor. Initialize has nothing to do with that. Let's end constructor there. Plonk that there for now. So now we need the capture device, which we don't have, which is an audio capture service. And in here we called that audio interface service, which is now audio capture service. So that becomes this, the data available becomes that, and we start capture. Now because this has, we bounce back in here a moment, store device ID, initialize, and start. See, now start recording is automatically starting, so you don't need to call start as well when we do this, but we will by default for now. So start recording, and you can see record and pause are the options we give it. So start the recording paused. No, it does. Start the recording paused and use channel play. So start recording, but in a paused state. Yeah, so now the initialization just gets it ready for recording, which is what we want. So that's fine. This is already in the interface, I believe. Yep, get channel config. But we also now need in the configuration to fix this, import missing files. We need to set loudness. So this wants to provide a callback in order to send this to the view model that the view model can bind to. So similar to how we've done the wherever we've done it, this data available here, which we also don't have. The view model could bind to data available, but that's not really relevant, I don't think. The start is that we need to expose. So we carry on down, we should have a start. So here you go, you got public start and stop, which are just functions that need to be exposed here. So you just literally need void start, void stop, stop capturing audio, start capturing audio. And then instead of duplicating these comments, when you come to here so they actually have a comment, otherwise they're blank, if we do 3 comment lines and put inherit doc, and you don't need the cref, that should automatically inherit from the interface, you'll now have a documentation when this is generated will inherit from the interface that it's coming from. So we don't have to duplicate comments, but you also aren't left with a public method that has no comment. So you'll see all this is useful when you come to generate public documentation. So we have the start and stop, and now we need to, we still have on the clipboard this data available to calculate data, which is this thing here. and we haven't used that yet. So we've done data available, which is exposed here. I don't feel we need that anymore. I don't think we should expose the data available. It should be a self-contained thing, but at the same time, we do now want to change this to a different kind of event to call back when the LUFS has changed or when audio is changed. So we probably want to make our own handle that comes back from here, or our own handler that comes back with all the changed audio. So we probably want to add a new class called audio chunk data, and that will be information about a single chunk of audio. That's what I'm thinking this will be. And in there we can have public, and I guess it might as well be double LUFS. And there's multiple LUFS, so if we open up the real Julian loudness meter a moment and pull this in, we have short-term LUFS, integrated loudness. So all these need to be added to our model here of things we can calculate. So we'll have short-term LUFS, and this really wants to just be, this can be a record in this case, and we can use a shorthand for record. And we'll use the record because it's only going to have public properties, and we can also use a short term. So think of a record like an immutable class. So we'll do a public record audio chunk, and then we can define it like this. It's a little bit different, but if we do that, then we'll effectively get a record, which is like a class with a constructor with short-term LUFS in. So this will be a public property on the record, and it's also easy to instantiate. So we'll use a record for this. We have short-term, we have integrated, and then because we've got a lot, I'm also going to chunk these onto new lines. Then we have loudness range. So all I'm doing is copying these off the Julian loudness meter, which is effectively our UI as well. We then have real-time dynamics. This bar here is this LUFS. So this is loudness. This part here is just pure loudness. Or rather, this is pure loudness, this up and down bar here. This looks like it's, for the most part, I'm pretty sure, just exactly loudness as it's happening. This arrow, rather, is short-term LUFS. So we have loudness and short-term covered by this bit here. And then this bar here, again, you can see is just short-term LUFS and true peak. So I think we have everything we need there now in this chunk of information we need to report about. And now we just need to make a public event for it. So public event, and if we just do an action that returns the audio chunk data, we can call this audio chunk available. And this will be a callback for when the next chunk of audio data is available. We need to now invoke that when we're ready. So let's just go back to here a moment. We know the constructor's fine. We know this is channel configuration. So this can be channel configuration methods. Capture audio methods. So procedure is literally the callback from when we initiate the record start, like here. So we can probably rename that now as well to audio chunk captured. So it makes a little bit more sense. Then here, instead of invoking the data available, which all we did was calculate values, we can now just call calculate values directly. And it doesn't need the length, so we calculate useful information from this chunk. So that's that call done, that call done. Calculates usable information from an audio chunk. So we do everything we normally do, which is fine. We get the extra LUFS there, which is fine. And then here now, instead of doing this dispatcher UI, view model loudness, all this lot, that will be done by the view model. Instead, we just want to make a new, in fact, we can do it all in one line. So we can do, what did we call it? Data available handler, maybe? Audio chunk available. So audio chunk available. If there is anyone hooked into it, we will invoke. And let's make a new audio chunk. And there we have everything. Then we can fill these in with information after. So now we will fire off this chunk of information to listeners. We now bounce back to the view model, and all we need to do on start capture is to listen out for these chunks. With mCapture service dot audio. Oh, and then we have to add that to the interface. Let's just paste this in what I've got on the clipboard at the minute. We need to add this event to the interface. So let's go to interface, add it to here. And then what we also want to do is move the comment from the class, paste it into the interface, and back in the class. If you remember now, we do inherit doc. Like so. We don't need that delegate anymore. We calculate the values, and now in here, this is where we actually do our audio specific calculations in the correct place. Our view model, or now our view, I think if we just pop back to there, is completely void of any knowledge of audio. So I think the view model is now, or the view in this case is done fine there. The view model is almost done. We have public properties that we still need to bind to with these that we're about to do, but I think for the most part here, we are done. We can get the channel service there. We can new up this interface, which gets passed in. And for the design time, we just new up one. We've seen that. That's all fine. Initialize is the temporary code for the position of the arrow, which for now we'll just leave in. So we'll just leave that code in for now for the movement. All we'd have to do is bind it to the correct value. And then on capture, we now have here the audio chunk available plus equals, and we could move this off elsewhere, but to be honest, I don't really think we need to for now. We've got the audio chunk data, and we can just bind to the UI, or in this case, we already have the view model, so we now just need to bind to this short-term loudness as audio chunk data dot short-term LUFS, and that should now output the same. Start capturing audio from the specified device. So now I think we have everything we need, and we've just shifted things around, commented things, and bound things differently. So let's just give that a build, see what we've missed. I'm sure we've probably missed something, or something's going to be wrong for the first time. Dummy interface doesn't exist. And that is because we are on initialized framework. Yep, we need to now inject the audio capture service, which again, this shouldn't really be called generically audio capture service now, because this is very specific. This is the type. So this is a base audio capture service now. and that makes it a very specific implementation. So when we come to replace it, it could get replaced. Let's build again, see if we've missed anything else. And that's all built apparently, so let's give it a run and see if we still have the LUFS fully binding through or whether we screwed anything up. And that's working straight away. So you can see this LUFS is actually working with me talking. So now let's just bind all of these other properties to the actual values. And now they're in the correct place, which is the view model. All we need to do is make a new view model property for each one. So again, as a reminder, we have them, but there's also the reminder in the chunk information here. So the audio chunk information has it all. And we have short-term, integrated, loudness, real-time, average, momentary short, short-term max, true peak. That will make view model properties for all of those. And we now just need to bind them here. So it's nice and easy. So integrated loudness, and we'll do a similar thing to this. Then we've got loudness range. That's all of them bound. And then now we have to actually bind them to the view itself. So if we go into the view, we flip it round and we find here where we've done binding. We can now just replace each of these with the bindings as well. And then just to make sure we have something that at least looks useful visually for now, instead of just zeros, I'm just going to do like LUFS times 0.9. Just going to make it something, useful. So the data's actually changing on screen and looks right, and then we can correct all these values when we come to actually write the audio code to process, these specific types of value, but that's not relevant to, the Avalonia side of things. So I'll just put a note to do, make these calculations correct. And now I think if we run this, we should see all of the UI updating and changing. Now, it obviously won't be right other than the loudness, but we should see the UI now moving around and doing everything we need. And there we go, we can now see all of the UI updating. So you can see all this moving around and updating with values that are obviously, this is correct, and then this is just a slow progression downwards of the real values. So I think now the only thing left to do is to make this arrow that's moving smooth here, move smooth like this. So we'll do I think for now, just a loudness meter on the bar, which is easy. So we'll make this bar move up and down with the actual LUFS. And then the arrow here, as you can see based on the real one, it looks like a delayed kind of elastic spring. So we want to work on, I think for now, just having it be the LUFS value, but trailing behind and doing just a slow movement. So at least it's smooth. So like you set the value from 0 to 100, it will progressively, in an elastic fashion, like an S-curve, work its way to 100. So like a trailing follow. So we'll do them next, and then we'll move on to the graph. So hopefully this is useful. This kind of clean up and make you see how you now should structure your service and your view model, and that your view should stay clean. But it's perfectly fine when you're fleshing out what you're doing to not waste all this time. Imagine if we'd wasted this time building this interface and doing this for every version of the audio capture that we were trying to do through the various different ways. There's no point doing this kind of nice, clean, correct way until you've found something that you like and that you're going to use. So just bear that in mind when we make things. Don't be afraid to just make a mess to start with, hack things in, make sure you're happy with them. And only then, once you're happy, refine your work. Don't start with everything perfectly refined and commented and cleaned in the right places, only to find out the thing you're trying to see if works doesn't work and you have to rip it all out again anyway. So that's it for this one, guys, and I'll catch you in the next.